In this tutorial video, I will demonstrate setting up load calculations investigating fault conditions. We begin by setting up the base project. We will simulate power production loading with a variety of different fault cases. The fault cases will be switched on and off within MultiSetup. Let's vary the wind speed. We're using the constant wind model for this demonstration. We will examine 3 specific wind speeds. We need to investigate 5 different fault conditions. However, some of the fault conditions are only relevant to certain wind speeds. We will use a custom parameter to define this relationship. We need to test condition A for all wind speeds. We need to test condition B only if the wind speed is equal to 14. We need to test condition C if the wind speed is 12 or 14. This is C# syntax. Faults D and D need to be simulated for all wind speeds. Custom parameters do not directly have an effect on the calculations. Fault type defines 5 different fault cases. However, at the moment, these will not affect the calculation at all. In order to set up the variations in the calculation, we need to add calculation parameters which reference the fault type custom parameter. Fault type A is an external controller fault. If fault type is A, external controller fault is enabled. We can delete the else if, else external controller fault is disabled. Fault B is a pitch fault. It's a constant rate failure on all 3 blades. And here I have duplicated the configuration for the pitch fault on all 3 blades. With this configuration, the pitch fault rate from the base project will be used. However, we need to investigate different pitch fault rates. We are interested in pitch fault rates of 25, 50, 75 and 100% of the maximum pitch rate. We can get the maximum pitch rate from the base project. In this base project it's 8 degrees per second. We can use a custom parameter to define those proportions. We will now set the constant rate demand parameter from the pitch faults folder based on the maximum pitch rate and the pitch rate proportion. Here we have the 4 different pitch rates for this wind speed 14 meters per second. This is the maximum, these are the proportions, and here we have the resulting rate demand. Let's label the calculations with the fault type. Select use value. For the calculations with fault type B, with the varying constant pitch rate, we need to add a label into the path to show the pitch rate demand. We can do this using another custom parameter, pitch rate label. This gives us the pitch rate on the end of the path. We will now configure fault C. Fault C is a single blade pitch seizure at time. So we'll find the pitch fault type parameter for blade 1. We'll add another statement into the expression. The time for this seizure will be defined in the base project. Finally, we will set up faults D and D. These are generator faults. Generator short circuit. These would be differentiated with a different short circuit input file. We can now review the calculation summary table to see what we've set up. Speed 10 has faults ADE. 12 has the same with the addition of C. 14 has the same with the addition of B. Fault A corresponds to an external controller fault. Fault B corresponds to a constant rate fault on all 3 blades with 4 different pitch rates. Fault C corresponds to a single blade pitch seizure. Fault D and E corresponds to generator short circuits. That concludes the demonstration on setting up load calculations for fault conditions.